Hello everyone, today we are taking a look at the Racebase flight controller. So just like most of the products that I show you on this channel, I've actually lived with this flight controller for a couple of months now. So I'm quickly going to show you how it's set up and how easy it sets up, and the fact that it's got OSD and the controllability of your PIDs and rates through the FPV. So let me tell you what some of the tabs are. Now, the video out and the video in has all been placed on the very front of the board, most likely where the camera and video transmitter is going to be. So across the top, going from left to right, we have video out, then the power out, and the ground for your video transmitter. The voltage that comes out of the central pin is the voltage that you actually put into the board. If we flip it over, then we can see the video in, the power out, and the ground, which will go to your camera. So to recap, from the left is video out, the voltage out to power the video transmitter, and the ground out to power the video transmitter. Looking in the corners of the boards, you'll see these circles and squares. So this is where your ESCs will actually connect to. So this is the signal and the ground for the ESCs. And the easiest way to remember how to wire that is that the ground goes to the round and the signal goes to square. Now, if you use a Spectrum radio, this FC also has you covered with the top right hand side with dedicated ports for the Spectrum receiver. So that's 3.3 volts, the ground, and the RX. The next square hole down is where you're going to take the voltage in. Now, this flight controller can take power from 2 to 4 cell. So on the square here is where you're going to run a positive cable off the power distribution board up to this square. Next to it is the VBAT. Now, when you're doing the VBAT, you will want to bridge the power in and the VBAT over together. Now, the easiest way I find to do this is to have a slightly longer unshielded piece of cable here, and then I'll thread it through and bend it over to the VBAT and then just solder the both of them together. So as you can see, that threads right through. It's longer than normal. I'll then bend it over to VBAT and just solder it in place like so. Now, the reason you're going to want to do that is so that the flight controller can read the voltage in VBAT, so it knows when to give you alarms, and it also gives you the OSD information on the screen. So going down is the voltage in, your VBAT, then you have your ground, which will come from the ground on the PDB, and then the last circle is a 5V out should you need an extra 5V. Continuing around the board, on the bottom right hand here we have another 3 tabs. Now, this is for a current sensor, but we're not actually going to use this, but just in case you're wondering, it goes ADC, ground, and then 5V on the right hand side. On the left hand side we then have our receiver tab. So going from left to right, we have the RSSI, we then have the PPM and S-bus port, then the 5V out and the ground. So as I mentioned, on the top of the board we have our video outs, but on the bottom of the board we have our video in. So this is where you actually power and plug the camera into. So this time it goes from left to right with ground on the left, then our voltage out to power the camera, and then we have the video in, so the camera actually goes into the right hand side. And the last tabs on the bottom of the board here going from left to right are plus and negative. So this is for your buzzer. So if you want to set up a voltage alarm or lost alarm, then this is where you will wire that in. And finally, the 4 tabs here are for the LEDs, so you can actually assign LED colours through the OSD and have them blinking and changing depending what your flight is doing. Now, the voltage that you get out for your camera and VTX depends on the voltage that you put in. So if you put a 4-cell in to the flight controller, then on the center pin you're going to get 4-cell power out, but it's going to be a filtered power supply, so you're not going to get any of the issues with the breaking ESCs and things like that. Your video signal should be nice and clean, and that goes for the camera and the VTX. So let's wire this all up and see how it looks. So we're going to wire in our camera VTX at the very top here. So we're going to have video, voltage, and ground. Then we flip the board over and we're going to add our wire for our camera. So again, going from right to left, we have video, voltage, and then ground. And that's your video transmitter and camera now wired in. And now I'm going to wire in my S-bus receiver. So from right to left, we're going to have ground, then our 5V out, and the signal for the receiver. Now we're going to add a cable for the voltage in, so I'm just going to put a blob of solder on the VBAT there, then thread the cable through, bend it over to VBAT and solder it all in place. Then in the hole underneath, I'm going to add another cable. This will be on negative, so this will go to the ground on the power distribution board. And because I like having a buzzer when I lose my quad, then I'm going to add the buzzer onto the rear of the board at the bottom here. And that's it, our flight controller is all now wired in, ready to be dropped into an awaiting quad. So here's my quad with the motors and ESCs all wired onto the power distribution board, and it's just awaiting the flight controller. So first things first, we're going to add the power. So the voltage in, which is this cable, is going to go to the positive on the power distribution board. Then we're going to do our ground cable onto the negative or ground on the power distribution board. So that's our power now going into our flight controller, which has to be 2 to 4 cell. You don't need to be using any 5-volt regulators for this. And now all I need to do is solder in the signal cables for the ESCs. So in each corner of the flight controller you will find the ports for the signal in and the ground, remembering that the ground goes to ground. Now you may notice on my ESCs that I actually only input the signal wires, and that's just for the specific ESCs. Normally your ESCs will have ground and signal, unless they are like mine. And that's the flight controller all wired in. All we have to do is bolt it down, plug in our camera, VTX and receiver, then play around in Betaflight and we're ready to fly. So when I got the flight controller, it came with Betaflight 3.0.1, and I decided to upgrade this to 3.1.0 because this allows the D-Shot capabilities, and that's what I have on my ESCs. So looking through the GitHub here, we can see the Racebase hex file is there ready to be loaded. So download the hex file and then go to Betaflight on the firmware flasher. We're going to load from local, so we're going to actually load that file that we've just downloaded. Mine's in my downloads folder here. Double click that and then it's ready to flash. Now when you press flash you'll see that it won't connect to the bootloader. So unplug the USB cable, then you're going to need to bridge these 2 pins here with something metal. Then plug the USB cable back into the computer. This will start up the flight controller in bootloader mode. So now when you go back and press flash firmware, you'll see that the firmware actually starts to flash onto the flight controller. And then we'll be able to go up to connect, and we will now have version 3.1.0 on there. You can verify this by typing version in CLI, and here we can see 3.1.0. You can then set up the flight controller however you wish. Here you can see I've got UART2 selected with the serial RX because I'm using SBus, and then the usual parameters through here. So I'm using D-Shot 600, so I'm selecting that. Then checking I have the SBus selected and my maximum voltage because I like to use high voltage. If you ever use high voltage and find that your quad starts beeping, it's probably because the maximum cell voltage isn't high enough. A lot of the options are going to be specific depending on what you want set up. So I'm going to put air mode on permanently on mine and make sure that the OSD is selected. And don't forget to press save and reboot when you've finished changing any of the parameters on each page. Now, a lot of people like to talk about PIDs. Now, I'm going to tell you a secret. I fly completely stock PIDs. All I do is go in and set super rate to 0. Then I'll put my RC rate to 2.20, the yaw rate to usually around 2, and then I'll use 0.65 expo on the pitch and roll and 0.20 on the yaw for RC expo. Continuing through to the modes, you can set your arming switch, the beeper, and then the flight modes. If you want stabilized, then remember to enable angle. Because this flight controller has a built-in OSD, you can go through and change all of the parameters here. Whenever you make any of the changes on here, so when you click one of the switches, you will notice that it changes on the Betaflight screen here. So if I disable this, you'll see that the bars disappear. You can also do this through the FPV screen later, and I'll show you how to. If you want to change the look of the writing, you can click on the font manager in the bottom right hand side, so you can change the size and the boldness. So before I go out and fly, I'm going to make sure that the quad is doing what I want it to do. So I've plugged in the receiver, I'm checking that my beeper and that my arming switch is all working, and then I'm checking that the motor directions are correct. The flight controller does allow the pass-through for BL Heli, so you can change the direction of your motors in software. So switching over to our DVR, this is what you will see when you first power up. And because I changed some of the OSD settings in Betaflight, we have minimal information on the screen. So we just have our voltage and our flying minutes on the right hand side. The blue HPI that you see in the bottom left hand corner is actually set in the camera, not on the OSD. Although you can add a nickname into the OSD. So to open the OSD menu, have your throttle at 50% and yaw left and then pitch up. And as you see, it brings up the main OSD. You can then use your sticks to go up and down and in and out all of the menus. So to go into profile, we're going to roll to the right, bringing you into the PID menu, and we can then go in and change the PIDs if we wish to. So for example, we'll go all the way down here to pitch derivative, and we can change that value up and down. So moving the stick left and right changes the value, and moving it up and down then changes the choice. So for example, we're going to go down here to the rate, then press right, and we can change the rate profiles. So earlier in Betaflight, you can see that I set my rates to 2.20, my yaw rate was at 2.0. We can also see that my RC Expo is at the rates that I set earlier at 0.65 and 0.2. So I won't go through all of the options on here, but you can go through and change your screen layout, the active elements. You know, these are the places that have the voltage and things, so you can change all of that through here. You don't have to do it through Betaflight. You can change your LED colors and so on and so forth. So it's actually very feature packed. So as I mentioned, the active elements here, we can see we can go in and swipe right to select yes or left for no, to enable and disable different things. So with the quad fully set up now, let's head out for a fly. So as you saw, the flight went really well, and I was flying on the stock PIDs. You can see in the bottom right hand side there, it's flashing now that the timer is over 2 minutes. I set myself a 2-minute timer just so I know usually when I'm going to race, the races last no longer than 2 minutes. So it's basically just for me to judge how much time I have left in a race. So in conclusion, this is a really nice flight controller. The OSD function performs flawlessly. There's no lag between making any movements on the sticks to what you're seeing on the screen. Having the ability to change any of the rates is really great for me. So if I'm racing, I can dial those rates down just slightly, and then if I want to have a bit of fun, do a bit of freestyle, I can then lift them back up later without the need for any computers. The fact I can change the LED colors as well is really helpful for the racing. So that's it for today's video, guys. If you have any questions, then ask them below. I also have links in the description to this particular product. So thanks for watching, and I'll be back soon.